Hi, my name is Alana Hudson, and this is my Chem 1000 third video submission. So we'll begin with number one, I guess, the first part, part A, which asks to give the rule for the chain rule composition of three functions at f, at g, at h. So in this case, I substituted my f for c, my g for b, and my h for a of x. So in other words, I'll just write that f is c, b, a. Okay. So the derivative of c of b of a of x is just like this. So for chain rule, we know it's the derivative of the outside times the inside. So the derivative of the outside is the derivative of c of b of a. Nothing changes on the inside. Then for the outside is the derivative. For the inside, you'll start with the derivative of b. You work yourself out in. So the derivative of b of a of x, again, nothing changes for a of x. And last but not least, derivative of a of x. So again, working from your outside in, derivative of c of b of a of x, nothing changed. And then starting on your inside, derivative of b of a of x, nothing changed. And then the derivative of a of x. And so as an example, we'll try the derivative of sine ln at x2. So your c of x is sine x, your b of x is ln x, and your a of x is x squared. It's really easy to write it out this way so you know to work from your outside in. So outside is cosine of ln of x squared because the derivative of sine x is cosine x. Derivative of your b of x, your next inside is the derivative of ln x, which is universally known as 1 over x, and so your x here is x squared, so it'll be 1 over x squared. And then the derivative of your absolute inside, which is your a of x, x squared, is just naturally 2x. So your answer here will be cosine ln of x squared times x squared times 2x. Okay, so the next problem actually asks us to work one out. So the derivative of e to the sine x squared. So raised to the power of sine x, e raised to the sine square root of x. E raised to the sine square root of x. So we start with the outside, which is derivative of e to the u. And e to the u derivative is e to the u times u, the derivative of u. So e to the u, so it's just simply what we have here, which is e raised to the sine square root of x power times the derivative of u. So again, the derivative of sine is universally known as cosine, so it's just cosine of x, which is, in this case, cosine of square root of x. And then finally, the square root of your total inside, which is square root of x, which if you rewrite it is square root x equals x to the 1/2. You multiply the coefficient beginning, which is just 1 to the 1/2, and then you move it to the bottom of the denominator. So the derivative of x square root is just 1 over 2 square root of x. When you simplify this and putting it in fractional form, you'll get e raised to the sine square root of x times cosine of square root of x over 2 square root of x. The question also asks us to solve for if x was pi squared. So the last thing you'll be doing in this case is just substituting x squared for wherever you see an x. So now you'll have e raised to the sine square root of pi squared times cosine of the square root of pi squared all over 2 times the square root of pi squared, which simplifies to negative 1 over 2 pi. Okay, so the next question, get the camera fixed. Okay, so the next question is number 41 from the section 3.7, which asks us to find the 2 points where x squared plus y squared plus, let me read that again. Find the 2 points where x squared plus xy plus y squared equals 7 crosses the x-axis and show that the tangents are of these points are parallel. What's the common slope of these tangents? And here we'll be using something called implicit differentiation, which is basically solving for y and x, both their derivatives at once. So in this case, dy over dx, the implicit differentiation of x squared plus xy plus y squared equals 7, is negative 2x plus y all over x plus 2y. After you implicit differentiation and you find the dy over dx, your only next step is to do as the directions say, which is to find the 2 points where the function crosses the x-axis. And we know that when a function crosses the x-axis, y equals 0. So to get this, we just plug in 0 to the original equation for all of your y's. So you'll get x squared plus x times 0 plus 0 squared equals 7. And then you'll get x equals plus or minus square root of 7. You got to remember with square root, it needs to be plus or minus because the number on the inside can be plus or minus. And now you would just solve for your plus or minus square root of 7 into your dy of dx. So your dy of dx for the positive square root of 7, 0 will be negative 2. And your dy dx of your dy of dx for your negative square root of 7, 0 will be negative 2. Most noticeably, negative 2 does equal negative 2, so the slope of the first one equals the slope of the second one, which of course means that the two functions are parallel. And the common slope here is negative 2. Thank you.